Hello, my name is Dr. Esther Trufan, and in this video, I am going to share the reasons why you will not find quizzes in the Experimentium collection. In our experience, this is how quizzes tend to work in the lab. The student comes to the lab, then the first thing they do is take a quiz. Then, regardless of how that quiz went, the student will participate in the lab experiment. Then, using the data they collected from the experiment, the student will write a report. And only the following week, when all of these steps are complete, will the student get a quiz grade. Now, what does this teach the student? The first is that the lab always starts with a stressful experience. Regardless of how predictable the quiz is going to be, the student will learn that they don't know what they will encounter in the lab. It's always a surprise because the experiment changes. The other thing that they'll learn is that they can participate in the lab regardless of how well prepared they are, because their quiz performance has no impact on their experiment participation. And then finally, they won't know if their level of preparation for the experiment was enough until they finish writing their lab report. And at that point, it may be a little bit too late for it. So let's explore what quizzes are actually trying to accomplish. The main reason why instructors would give quizzes to students at the beginning of class is mainly to ensure that the students come prepared for the experiment. Another reason may be to ensure that students will arrive to the lab on time. And then finally, they may be trying to evaluate whether the student is familiar with the conceptual background and the calculations associated with the experiment. Now, all of this are valuable considerations of student participation in the lab. But how can we ensure that the student connects their actions to the score on the quiz? Because if that connection is not made explicitly, then the student may be getting the wrong message from the experience. So let's start first with the preparation for the experiment. What kind of preparation is valuable and effective for a student before they begin participating in the lab? There is a research article from Miles Pickering from 1987. And in this article, Dr. Pickering is looking at the pre-labs that students prepared before coming to the lab and participating. What he looked at is, are the students copying the protocol verbatim from the provided resource, or are they creating their own version and interpretation of that protocol, cutting out the information that they find not relevant at the time of the experiment completion? And what they found is that students who come in with a telegraphic, which is his version of a simplified, in their own words, description of what they're going to do, are significantly more efficient in their performance of the experiment. Later, if you read the rest of the paper, you will also discover that the level of preparation had a limited impact on the student's success, meaning the efficiency with which the student performed the experiment has limited impact on how much they learn, because that learning was measured on other criteria. So what do we take away from this study? Students should come to the lab prepared, having answers to the following questions. What type of measurements will they collect? What are the required steps to perform any new techniques correctly? What kind of equipment and what kind of chemicals will they work with? It's straightforward to assume that we could measure all of this with a quiz at the beginning of the class. But if there's no quiz, how can we ensure that the students come prepared? Well, we could use a pre-lab with enforcement. And that means that in that pre-lab, we require the parts that are essential to students completing the experiment. That is the protocol, the chemicals, and the equipment. And the enforcement part of this is that if the student doesn't complete the pre-lab, then there are consequences. Those can be either not allowing the student to participate in the experiment, apply a grade penalty, or something else that we find appropriate for connecting the lack of preparation to the consequence that follows. In the Experimentium collection, you will find that our pre-labs are formatted for these 3 categories, and they do not require any further tasks from the students. We recommend that the no participation in the experiment be enforced to ensure that students know what the expectations are and that students come prepared for the experiment. On-time arrival ensures that all students have access to all the information that is shared in class, and that could relate to scoring practices, class culture related conversations, or potentially updates and demonstrations. The students should be there so that together they can plan and work safely from the start of the class until the very end. They need all the time, especially at the beginning, to make sure that they can effectively coordinate and delegate the work responsibilities for the day. And there are other reasons why they should be on time, one of which could be simply respect the time that is allocated for the work. So if there is no quiz to ensure that students arrive on time, then you could use class culture with enforced boundaries. Here, I would like to separate into 2 categories. The student may be late with no notification and no good reason other than they did not plan. Or a student could be late with a prior notification if something occurred between the time that they intended to arrive and the time when they are actually arriving. And I recommend that you treat these 2 categories somewhat differently, just so you can encourage your students to communicate with you before there's a reason to implement a penalty or a boundary. If a student is late with no notification, it is important that you have a policy for that. And that policy could be anything from no participation in the experiment if, and here you can define under what conditions that applies. It could be if the student is more than 15 minutes late without excuse, then they are not allowed to participate. But you can customize this policy for what works for you. You could also apply a grade penalty, or you can come up with a different way to connect the late arrival to the associated consequence. Now, if a student made a meaningful effort to arrive on time, but something occurred and they notified you ahead of time, then you may choose to respond to that behavior slightly differently. If the arrival is so late, maybe an hour or hour and a half later than your actual start time, then it's very appropriate to say no participation in the experiment, or even a shorter timeline may warrant that. A grade penalty may be applied, and again, here you want to be very specific about what the requirements are and what is the standard that will be upheld. You may choose to deliver no consequence if there was prior notification, or you can come up with your own custom response to that. The important thing is, if timely arrival is important for you, find ways within the class culture to ensure that students connect their behavior to the culture that you would like to be maintained. And then the third reason why one would have a quiz is that familiarity with the conceptual background and the calculations associated with the experiment are genuinely helpful to the students. They will help students perform relevant calculations, interpret their data, analyze results, maybe even interrogate assumptions that were made in the course of the experiment, and allow for connection between the theory and the practice. It's not debatable that these are all valuable functions. The question is, would not this be more effective after the students completed the experiment and have actual data to work with? I would like to direct your attention to an article from 1984 from Alex Johnstone. He said, "It would be helpful if we were to stand back and examine the sources of the difficulties that students have with chemistry." And he identified three main possibilities for that. The first is that the nature of science, or chemistry here, makes it inaccessible. In other words, chemistry is just difficult. The second reason is the methods by which we traditionally teach chemistry may raise problems. And the third is that the methods by which students learn may be in conflict with either the difficulty of chemistry or the way it is traditionally taught. And upon the study of these options, what Johnstone ended up concluding is that the students only have a small working memory. And to be honest, we all have a small working memory. We can only hold so much information that can be applied in our heads at the same time. And so if we severely overload this working memory by our teaching methods and our testing methods, then there is very little working memory left for the students to pay attention to things like observing what is occurring in the lab, making sense of their observations, drawing conclusions from the trends that they're observing. The working memory, according to Johnstone, is that part of the brain where we hold information, work upon it, organize it, and shape it before storing it in long-term memory for further use. The important factor is that this working memory space is severely limited in size. Any overload of it leaves us no space for thought and organization, and so faulty or even no learning takes place. The fact that we can accomplish the same consequences with something other than a quiz, and at the same time respect that the working memory of the student needs to remain available for conducting the experiment itself, not just for entering the classroom. The Experimentium collection does not recommend that you use quizzes. For a full syllabus template that does not include quizzes, visit experimentium.org.